This video presents a demonstration of using inter-process communication accomplished via anonymous pipes for software integration. This presentation assumes a standard GNU Linux distribution with the GNU compiler collection installed as the target platform. Standard input-output streams are often used for accomplishing inter-process communication. So given standard input-output streams like console output or console error, inter-process communication can be used for interfacing these processes either via redirection, where the data is read or written to a file on disk, or via piping, where the data is sent between running processes. This approach can be used for creating software pipelines or software systems by interconnecting programs or software components. Anonymous pipes enable interconnecting these processes, and they are widely used at the shell as well. Here, the output of one process is piped or connected as input to another process. This enables creating ad hoc software systems or software pipelines. For example, at the Linux bash shell, we can list all of the processes for a user simply by using the ps command. But if we want to restrict it to a subset of a user or to a specific user, we can simply pipe the output of ps command to grep, which searches for all of the lines that ps outputs that contain the word ravdm and only print those matching lines. In other words, we essentially accomplish listing processes for a specific user. Of course, we can connect multiple commands this way, where we can take the output from the ls command, supply it as an input to another command called tr, which removes or squeezes out white spaces, and then take the output from there and give it to the cut command to cut out specific columns of output that we need. And this essentially accomplishes the task of listing the file name and the file size, which is outputted originally by ls, and then we are able to pipe that data to multiple processes to view the results in a more concise form or to get the output that we care for. And this is how we are connecting examples of connecting software components to build ad hoc software systems. Of course, inter-process communication with pipes provides a more powerful approach even from a programming perspective for reusing software components. This methodology improves code reuse because we can reuse programs that are already existing, and reduces development overheads because we are reusing software, and also reduces some of the maintenance costs. Let's look at this from an example. So using an example to motivate this application, let us assume that we want to do some basic processing with a text file. So let us assume that we want to calculate the average length of words in a given text file. Pretty simple application. Here we are going to count the number of words that we have in the text file, and of course track the total number of characters we have encountered, so we can calculate the average word length. Here we're going to use a simple for loop, which is going to read words from some input stream, and it's going to track the number of words it is encountered, and then of course track the total number of characters in each word, so that we can then do a simple math and print the average word count. Of course, here we're going to open a file using an input file stream, where the path of the file is specified as a parameter to this method. And of course, it's always a good idea to ensure that we are able to successfully open the file for processing. So this is a very basic, very simple text processing application. Now let's add a twist to this. So the twist here is, rather than the files being simple text file, let us assume that the files are now encrypted. So in order to process this data, we need to first decrypt the file and then do the processing. Let us also assume that we do not want to store the decrypted data on disk, because then that decrypted data might be available to somebody else. And of course, let us also assume we don't want to use like a web service for security reasons, because we don't want to send our encrypted data across the wire to some other organization for decrypting. So this kind of sets up the context in which we want to do and apply inter-process communication. So keep in mind here, the task is to process encrypted files and to print average word length. And of course, in order to decrypt the file, we can use a standard approach, which is to use a library. This is a very commonly used approach. So when you use a library, you kind of have to now deal with some interfacing logic. Each library might have a specific way you may have to work with it. And of course, when you pull in libraries, you add more dependencies to your software system, and that can make your overall software solution a lot more complex than what we started with. An alternative approach is to use inter-process communication and pipes. Here, the idea is to reuse a standard software program called Openssl that can already do decryption of files, and Openssl is a pretty powerful software which is available on most standard Linux distribution out of the box, and Openssl gives you a lot of different ways to encrypt and decrypt data files and such. And here we want to use, if we reuse Openssl, it'll help us from reinventing the wheel by reusing a lot of the capabilities of Openssl. And since we don't want to store the data on disk, we want to obtain the decrypted data from Openssl over an anonymous pipe so that we can easily process the data. So here the idea is we are going to run the decryption, run the text processing in our program or our process. This is where we would do the simple for loop to count the words and such. But we want to process data from an encrypted file. So what we're going to do is we're going to create an anonymous pipe, and then we're going to run Openssl program as a child process to our parent process. Our process will be the parent, Openssl will be the child. And then we'll have Openssl get the data from the encrypted file, decrypt it, and give us the data over this anonymous pipe so that our process can then process the decrypted data and work with decrypted data just like we normally did. Let's see how we can accomplish this from a programming perspective. So here let's start with our default application that we've already seen, where we are calculating the average length. We want to retain most of the logic to be the same, so we're going to retain all of this logic in terms of the for loop and printing to be the same. The only difference that we're going to do is where we're going to read data from. So instead of reading data from a file, we're going to read data from a process. So here we're going to first throw away the part that we're going to read data from a file, and instead we're going to create a child process which is going to run the Openssl command for us along with necessary command line arguments to process the data from this file. Basically, it'll decrypt the data because of the -d flag and give us the data from the file in a decrypted form. So this operation of running it in a separate child process is very synonymous as if we could have run this command at a terminal. So we could have run this Openssl command at a terminal, and this fork and exec essentially accomplishes that task for us. In addition, we are also going to get the output from the child process. Here Openssl is our child process, and we are going to get the output into a standard IO stream, specifically here an input stream, so that we can then read data from that input stream and process word by word the decrypted data. And one more operation that's important is when we are running child processes, we should always wait for the child to finish so that we know that the child process has successfully completed. So this is the approach that we are going to use. Pretty straightforward. So instead of reading data from a file, we have now run a separate child process. The part that we haven't seen is how the piping is done to get the output from the child process into this input stream. And now let's take a look at how the child process class helps us with that task. Here is the child process helper class. Pretty straightforward class. Note that in this presentation we are not looking at some of the additional methods like destructors and such that are present in this class, but we are going to focus on the core methods associated with the child processes API. And of course here the documentation and the API documentation is not shown just for brevity. Let's look at the two key instance variables that help us with managing the pipes, the pipe buffer and of course the child output stream wrapper. Here, when we create a pipe, essentially the operating system creates the pipe and gives us a operating system file descriptor, which is essentially an integer. Obviously, we cannot do input-output operations with just a integer. So what we are going to do is we're going to wrap this integer into a buffer. In this case, it's called pipe buff, which is defined as an instance variable. So we're going to wrap it into that pipe buffer, which enables us to read character by character from the output of the data coming from the pipe. Again, here the file buffer itself is still somewhat of a lower level construct, so we're going to further wrap the pipe buffer into a input stream which eases reading and writing data, and in this case the input stream is called child output. And this get child output method basically returns a reference to this input stream so that we can easily get the data that is coming over the pipe, which goes through the pipe buffer, comes through the child output, and we get the output from there. And of course, in order to connect the child output and pipe buffer in our constructor, we are going to initialize the child output, which is the input stream, to read data from this pipe buffer. Notice that the pipe buffer is defined here, which is a buffer, and this pipe buffer is wrapped into this child output so that we can read data that is coming over the pipe and coming through the different layers of software. This is basically simplify the input-output logic that we've already created in our reference application. Now let's look at how this fork and exec IO method works in order to establish the connection. In this fork and exec IO method, which is going to start running in the parent process, first it goes ahead and creates the pipe. So here we get two ends of the pipe. We get the read end and write end of the pipe. These are file descriptors. Keep in mind these are integers that the operating system fills in as part of the pipe system call here. So that creates the pipe. Next, we are going to create we want to create and run the Openssl command as a child process. So here we are going to use the fork system call to create a child process. Remember, fork creates an identical copy of the running process that is the operation of the fork system call. So as a consequence, the pipe file descriptors that were created originally in the parent, remember we created them before we forked. So these pipe file descriptors that were obtained from the pipe system call are also present on the child process. So both the parent and the child process have references to these file descriptors associated with the single pipe that was created. Next, in our child process, we are going to close the unused end of the pipe. So in this specific case, the child process is going to send data to the parent, so it's only going to write. So we're going to close the read end of the pipe, thereby establishing the direction in which we want the data to flow. This is more as a precaution or as a good programming practice to close unused resources. In the next step, we are going to use the dupe2 system call to tie or wire the right end of the pipe to the standard console output. That's what this number 1 refers to here. It refers to the standard console output file descriptor. So we are taking whatever is the data that's coming from cout, and we are going to basically put it onto the pipe so that the data will flow over the pipe to our parent process. That's what this dupe2 system call does here. And then finally, once we have set up all of this, we change our running program to run Openssl by calling the myExec helper method with whatever is the argument list. Notice that this is a helper method. So whatever is the arg list that is given to us, in this case our argument list was Openssl. So the Openssl command starts running in the child process, and Openssl starts processing the data and starts sending the data over the pipe to our parent process. Meanwhile, in our parent process, remember that we have now two processes running. First thing that we do is we take our operating system level file descriptors associated with a pipe, and then we wrap it into our pipe buffer and the output stream to ease reading data, just as we saw before. And remember, we also set up the connection between the child output and the pipe buffer in the constructor so that we wire all of these data correctly. And this line of code establishes the connection between the pipe buffer, the file descriptor, and the pipe buffer to read data from it one character at a time. This is to ease reading data that is coming from the child process through the pipe to the parent process. Now let's take a quick look at the myExec helper method. Here, the myExec helper method essentially is a helper method to make a call to the exec VP system call to run a different program. So here, the first step in the process is to set up the necessary pointers that exec VP requires into a separate args list where we set up a pointer to each command line argument and the command that is given to us. Then we add the null putter to show the end of all of the arguments, the list of pointers in the args list. And here, of course, this code helper method assumes that the first entry is going to be the name of the command itself, or Openssl in this specific demo. Keep in mind, when execvp completes successfully, that means when Openssl starts running, this method will never return back to the calling process. So that means the running program, our program will be replaced with Openssl by the execvp system call. All right, now that we've done all of this work, let's make a quick demo to see how all of these works in practice. Here, I'm going to be running a standard Ubuntu distribution, and then I'm going to be using GCC version 9.3 for this demo. I've already set up all of the files here. I've got my child process header file and my implementation set up in a CPP file. Let me show you guys the main.cpp, which is just the example that we saw before. So here it's going to use the fork and exec helper method to run Openssl with the necessary parameters to decode the file name that's specified as a path. Then it's going to run the standard for loop to count all of the words, wait for the child process to finish, and then prints the average word count. Pretty standard application that we saw before. The main method basically checks to ensure that we have specified a command line argument and then passes the command line argument to this average length method as the file that needs to be processed. And before we run this program, let's look at how Openssl actually behaves. So here, if I wanted to decode this file, I can use Openssl, give it the cipher that I wanted to use for decoding. The -d flag basically says I want to decode. And then when you run it, it'll ask you for the password for decryption. I'm going to type in the password. And here is the actual data, the decrypted data that's in the file. So if you look at the encrypted data, it'll be different. What we want to do is work with this decrypted data. And this is what that Ipc program is also going to accomplish. So I'm going to run I'm going to compile the program with GCC, a pretty standard compile. And then I'm going to run the Ipc program. Of course, it wants me to specify the file it should work with. So I'm going to give it the file name as a command line argument. In this case, it's a secret encoded file. When I run it, internally it starts up Openssl, which in turn asks me for the same decryption password just like it did before. I'm going to type in the password. And then instead of printing data on the console, in this case, we have hijacked or obtained the data from Openssl back to the main process, which then calculates the average word length and prints it. So this is a demonstration of how we can reuse programs that are already available to us as part of the operating system to build on top of them and to build more sophisticated software systems by using inter-process communication via anonymous pipes. Keep in mind, just a quick recap of this Ipc approach is we can use Ipc as an alternative to using standard libraries and such. This is an alternative where we can reuse existing programs. In this case, we reuse Openssl to obtain the decrypted version of a file over an anonymous pipe so that we can do processing with decrypted data. And here in this example, remember we created and use fork and exec to run Openssl as a child process. And then we also use anonymous pipe to get the output from Openssl so that we can do some convenient processing of the data to calculate some word length and print the data out. And of course, it's important to keep in mind when you use child processes, it's a good idea to wait for the child process to finish. Programming with pipes is important and is very useful for creating many custom software pipelines. So here in this example, we just looked at a simple pipeline where there were only two programs running, but we can also have many processes that are interacting with each other, and sometimes we can also create cycles in there selectively to process data. We can also use different processes that are running in like a split and join type setup. So we can create different kinds of pipelines where we can split processes or split data between different programs and use them to build more sophisticated software for processing data. This helps us processing data in unique formats. In this case, we processed encrypted data, but it could be in different formats. We can also send data over the network or store data in this way into databases. So we can do all kinds of operations with different commands that people have built. In this demo, we specifically used the pipe system called to create an anonymous pipe. Then we used fork to create a child process and exec to replace our program with Openssl. And we use the dupe2 system call to tie or connect standard input streams to pipes so that we can hijack input output streams and get data over pipes from one process to another for doing custom operations. Hope you find this demonstration to be useful and interesting. Have fun!